class, this is a video tutorial on problem solving with trig functions. Scenarios involving trig functions simply require an understanding of how they are graphed, as well as being able to solve trig equations. So let's get into our first function here. So the function h of t, of this one here, this approximates the depth of a lake in meters at t hours after midnight. So part 1, it's asking what is the highest and lowest depth of the lake. Well, this is simply just asking about the amplitude and the center of this function. Now recall that the original function of cosine starts at 1, goes to 0, goes to -1, then back up to 1. Because we have been transformed vertically with that 3 and 2.5, I hope you can see that the middle of this function is going to be at 3. Then from this point, we add the amplitude of 2.5, and that gives us the highest point of this function, which is 5.5 meters. And since the middle is 3 and we subtract the amplitude of 2.5, we get 0.5 meters as its lowest. So the h of t can be written as the height of this is between 5.5 meters and 0.5 meters. Or you could write this in bracket notation from 0.5 to 5.5 meters. Okay, so let's now move on to the next question. What is the shortest time that the lake depth is the same as it was at midnight? So once again, with the original function of cosine, it starts at 1. This question is asking how long will it be, so how much time on the x-axis will it be before it gets back to 1. Well, in the original function, from 1 to 1, it takes a length from 0 till 2 pi. This is actually asking about the period of this graph. So to find the period, since normally it finishes at 2 pi, but we are horizontally translating it by this function here. So that's going to be divided by pi on 6. So this is going to become 12 hours. So the period is 12 hours. So if this function started at 5.5, which would be here, 12 hours passing, it will be the same, it will be the same height at 12 hours. Now that we have this, we can now sketch the function for this from 0 to 12 hours. Now since this is cosine, we know that it starts at the point, the highest point. So its top point here is 5.5. Its middle is that function here, or not function, that value here of 3. And its lowest point is going to be at 0.5. So we know it's going to go up and down from 5.5 to 0.5. So it should look something like what I showed you there. Now, another little trick that you can do for this, you can do all the transformations, which if you're familiar with that one, go for it. But since the critical points of cosine and sine actually happen at even intervals, at 4 even intervals, if you divide this by 4, that will tell you the length of time needed for the next critical point. So 12 divided by 4 is 3. So the next critical point of cosine, it goes down to its x-intercept at the next lot of 3. again, because we divided this by 4, every 3 hours is the critical point. So from, I missed it, should have been 3. The next one here is going to be 6. The next one here is going to be 9. And then the next one is going to be at 12. So looking at this, we can see that the function should look something like this. And there we have the function from the domain of 0 to 12. Let's keep going here. Part 4. What time or times of the day does the depth reach its lowest? Well, now remember that this function is saying that it begins at midnight. Notice that the lowest depth here is at 0.5, and it first happens at 6 a.m. So 6 a.m. is the first one. But notice that it wants for the full day, and this is actually only 12 hours after midnight, so this is 12 at noon. So the next time that it hits this lowest depth is, according to the period, 12 hours after this time here. So the next time here is going to be at 6 p.m. So it's at 6 a.m. and 6 p.m. And so this is how you can tackle this problem graphically. And now I'm going to show you how you might do this algebraically with trig solving equations. Now, the lowest depth here is at 0.5. So effectively, we are asking, when does this function, right here, when does this function equal the lowest depth of 0.5? So in effect, we are solving this trig equation. We can do this by, well, like we normally do with trig equations. Going to subtract 3 on both sides. So we get 0.5 minus 3. So negative 2.5. This gives us negative 2.5. 2.5 cos pi t on 6, and then we divide by 2.5 to get us cosine pi t on 6 equals negative 1. At this point, we need to remember what values give us, so what values of theta in cosine give us negative 1. So to do this, we take the inverse cos of both sides. This is in radians, but let's do this as a degree. So it's 180 degrees. So it's going to be pi t on 6 equals 180 degrees. But there's another value for that, because we want to go until the full, well, this is going to be 12 hours. We want 24 hours from this. So taking the next revolution from this point, we get 540 degrees. Converting these to pi, so divide by 180, divide this by 180 as well. These become pi and 3 pi. And then from this point, we can solve we can solve this now for these values. So it's going to be times by 6 divide by pi. So doing it for this coordinate or this value, this becomes 6 pi. Divide by 6 becomes 6. Likewise with 3 pi, 3 pi times 6 gets us 18 pi, but then we divide out by pi, we get 18. So at t equals 6 and t equals 18, you will get this height of 0.5, which corresponds to 6 a.m. and 1800, which is 6 p.m. Okay, so hope you can see that you can solve this using either the graph or with trig equation techniques. Please be aware that you have to learn both, because sometimes the graphs will not work for you. Anyway, so hope that gave you an insight into how we can solve trig problems. Hope to see you in the next video, and best of luck.